Okay, welcome to lecture 4.4. Here I'm going to explain the details of the McFadden paper, the measurement of urban travel demand. I think I got the title right. By the way, this is, as far as I'm aware, and I'm almost certain of this is the very first logit or probit or logit like estimation ever in social science. So, um, and this is one of the also early models where you call structural, where McFadden sets up. Now we just say run logit, run pro, but he set up the utility function. Here's the utility of something. That's the underlying latent variable, and then you make your choice of different goods. In this case, it's what travel mode to pick based on that underlying latent variable, the utility function. And he put some structure on exactly what the utility looks like. Okay, so you'll see that. McFadden eventually won the Nobel Prize, shared it with James Heckman, and I'm going to give a little anecdote about Heckman, even why they're intertwined in a sense. Let's see what else. Other thing I want to give you a little anecdote. The course you're taking is course I designed, although I borrowed heavily on a course I took in grad school by Jonathan Feinstein, who is an econometrician at Yale University. Feinstein took a similar course, or at least one of his teachers was Daniel McFadden. So in a way, I am like an academic grandson of McFadden. And so you all taking this course are like an academic great grandson or great granddaughter of McFadden. So he is spreading his influence, and it's coming through not only through his paper but the whole course. Actually, I suspect a very very big influence from him through Feinstein through and to me. Okay, here is the McFadden paper. Okay, so first. Okay, I'm going to explain the choice of which mode of travel a consumer takes. Okay, now we're going to just talk about a generic consumer, and one thing that could be confusing, I want to clear up first. I equals when I talk about I, it's the mode of travel. So I is going to equal what we'll call, you take BART, that's one, take a car, that's two, walk, that's three, take a bike, four, cab, that's five, something like that. I won't specify the actual numbers, but the idea is I stands for which mode of travel you take. It's not consumer I. Okay, now maybe what we should do is talk about consumer J. So by the way, the data for this, McFadden had all these surveys of people when they were asked, like, Bart is thinking about expanding another station, and so they're looking at these possible consumers around that new potential station, giving these surveys. Basically trying to estimate, would you take BART, and also looking at the people already living by a BART station. So they're using this to try to estimate what would be the demand for BART if they added a new station. By the way, supposedly McFadden was his estimates almost perfectly predicted at what the demand would be. Something like 1 or 2% off, or something very very tiny. Okay, so these consumers, these people who have answered these surveys, we would call them consumer J. I'm going to drop the J. So we're just going to pretend like we're looking at one consumer. Okay. Keep that in mind. All right. Now, um, if C sub I equals the cost of mode I, and awesome in dollars. So we're going to have this underlying latent variable. It's going to be the utility, or I call it, often we call it the utility. Instead, McFadden's going to call it the total loss. So instead of your utility you gain from taking, it's going to be the total loss in terms of bus fare, time spent, discomfort. So it's just the negative of the utility. So CI is the cost in dollars. Oh, and by the way, this total loss, it's going to be normalized, the units of this. So usually we have a utility function. Sometimes we'll say in utils, this kind of mythical units. But sometimes we'll actually talk about a utility function where the utility is measured in dollars. Okay, here we're going to talk about the cost which is measured in dollars. Everything is converted to dollars. This latent variable, the units are dollars, even though we might not see that actual variable. We're actually going to assume that the consumer sees all this, so that we're going to have like a random variable, which is going to be like the discomfort. It's random. I talked about this. It's random because we, the researcher, don't see it, but it's sometimes called a random utility model. So the utility or the loss to the consumer, to consumer J, is that discomfort. Consumer J, we assume, knows that. Even though we'll call it random, it's actually known to the consumer. Okay, but back to we're going to talk about some of the independent variables that McFadden would have gotten from this survey. One is the cost of modi, and this is in dollars, and this is things like bus fare. So actually, I'm not sure I mentioned bus as a potential. So there's BART, bus, cab. These are all like the fare, the amount of money you would spend on on that bus fare. And by the way, note this. Okay, I'm a little bit beyond the scope of the course for now, but let me kind of foreshadow what you would learn, and I want you to be able to learn by looking at things like a STATA manual or looking up these things. The likelihood function that we're actually going to derive at the end is I can't even remember the name. It's either multinomial logit or conditional logit, and I don't remember which is which. So every once in a while I'll have to use them. I look them up on Wikipedia, look them up in the STATA manual or whatever. And the difference has to do with the parameter that is multiplied by, that you multiply the independent variable by. Okay, so we're going to have this beta term, say, beta sub c. Okay, and that's going to be the loss in dollars. Okay, we're in the key is between multinomial logit and conditional logit is whether those parameters have a different subscript according to which choice the makes. So we're going to have the cost of mode of dollars. So we could call it beta is this cost. We're going to call it beta times CI. So if the bus fare is $3, beta is 2.6, beta is 2, the total cost is 6. Okay, if the cost to the cab fare is $5, it's just 2 times 5. Okay, sometimes, and I can't remember if it's multinomial logit or a conditional logit, you will put a subscript on the parameter. So it will be like the cost in terms to you, the consumer, even though it's dollars, a dollar spent on bus fare, if you have a beta I, so it's beta sub bus, beta sub BART, beta sub cab. If you do that subscript, it's like saying the dollar cost you pay is not the same in dollars depending on what you took. So $6 spent on bus fare is not the same as $6 spent on cab fare. Now that doesn't make sense. To me, a dollar's a dollar, okay? But there are some contexts where it does make a difference. And in this context, it does not. In the McFadden context, it does not. And so you would not put this little subscript on the according to what mode of travel it was. So it's beta, and it's the same. A dollar's a dollar, whether you're spending on cab fare or bus fare or what other else fare, bus fare or BART fare. But in other cases, you might put the subscript. So McFadden does not put the subscript, and this means it's a conditional logit, or maybe it's a multinomial logit. Like I said, I don't remember which is which. But remember, that is the difference between multinomial logit and conditional logit. It's whether you have that subscript on the parameters, and that subscript corresponds to which choice that the consumer is making. By the way, so we're going to set up this likelihood function, just like I said for in the last two or three uh, lectures or sub lectures or what the aspects of the fourth session. I talked about probit and logit, and you really didn't need to know those words. So you just had you knew the problem. You could describe the likelihood function. You don't even need to know how to execute a probit or logit in R or Stata. You just write out the likelihood function. That's what we're going to do here. I'm not going to use, say, you estimate it by typing in, I think in R it's called mlogit or clogit. And I don't remember which is which. All we're going to do is write out the likelihood function, and we're going to do like McFadden did. So when McFadden did this, the stat programs did not exist to run conditional logit and multinomial logit. You just had to write out the likelihood function, and that's what McFadden did. He programmed it in Fortran. Okay, if we were going to run it, you could do it in a simpler way. You use R probably, but the key is I'm just going to write out the likelihood function. Okay, but I want you to know for future use, it's called multinomial. You could run this in R or Stata by just writing out clogit or mlogit. I don't remember which one is which, okay? And the difference between the two is whether that parameter has a subscript. Okay, I wanted you to learn that. All right, I've spent a long time, sorry, on that. Next, another independent variable, t sub v sub I, and that equals the time in vehicle I. So the idea is on these surveys, you take a person that lives already by one of the existing BART stations, and you start asking him or her, well, if you were to take a cab, how long would it take you to get to work? If you were to take BART, how long would it take you to get to work? If you were to drive your own car, how long would it take you to get to work? So that I is according to the mode of transportation. That consumer would tell you the three different number of minutes, or I said three, maybe 4 or 5, if bike and walk and other modes of transportation in there. That person would answer on the survey, here's how long it would take me according to which I chose, which mode of transportation I chose. And that's TVI. Okay. Time in vehicle I, T A sub I equals access time for mode I. Time in. I said vehicle I. Maybe I should have said mode I. The idea is which form of transportation you're choosing. And this is access time. So, time in vehicle versus access time. Access time is, e.g., time it takes to walk to the bus stop. Okay. It also might mean how long you might have to wait. Uh, for instance, my son takes a bus to school. It's supposed to arrive at 7:35. That's the earliest it will ever get there. Usually the bus is like 7:39 or something. So in this case, um, but then my son it's like a 2 minute walk to the bus stop. This TAI for my son would be something like 6 minutes. With 2 minutes to walk to the bus stop plus the 4 minutes he has to wait. TVI, I think it takes him like 12 or 15 minutes to get to school. That would be TVI for my son would be 13 minutes, say. Um, okay, the next KI, so I equals comfort level of I. Um, and this is going to be a random variable to the researcher. So all these things we're going to call, instead of utility, we're going to call it loss. So it's like negative utility. So Ki comfort is like, call it maybe it should be called discomfort level because it's a loss. Okay. Um, okay. All right. If you're reading the paper, I think it's a little more complicated than it has to be, and it does things like um, it generalizes to the dynamic case where my choice today um, may affect the utility of my choice tomorrow. I think it has to do with like taking the bus. I learned how to get to the bus station. I think he even talks about things like buying a car. So if you buy a car, then you've got a stream of uses of the car. We're not going to do that. We're going to treat it as like a static case. And by the way, I think this is often, when you're reading complicated paper, often try to just imagine it as a specialized case of what the author has in mind. So I told you when you're reading the green papers, when theta was a parameter, a vector of k parameters, I said when you read it the first time, just assume that theta is a scalar. So same thing here, even though McFadden sometimes talks about the dynamic case, we're going to think of it as a static case. So it's one time you're going to take one of these modes of transportation. Okay. Um, okay, next. Okay. P sub W equals the consumer's wage. So the consumer, I said that's J. So I refers to the mode of travel. Okay, and then, this probably isn't so as important for the static case. But I think in the dynamic case, McFadden worried about inflation. You know what else you could worry about? There's price levels, different price levels in different counties or different areas around the Bay Area. So we have to worry about what he's going to call the price level. And so we're going to have a variable P sub F equals price of a consumer good. You know what? And I told you that we're going to convert everything into the utility as like in dollars. You know what? That's not quite true because we could have inflation and the price levels are different in different areas. We're going to convert them all to this unit consumer good. And I like think of it as a loaf of bread. Okay, and suppose there was only one kind of bread, and so we had standardized exactly what the consumer good is. So we're going to convert all the utility instead of dollars into how many loaves of bread it is worth. Think of it that way. Okay, so we're going to divide everything by PF when we're talking about dollars, and this converts it into how many loaves of bread that money is worth. Okay. we got PF. Okay. You know what? I think I've spent 20 minutes. I'm gonna stop there. So this was 4.4. Okay, so we fortunately defined some variables. Now I'm gonna give some equations about how we're gonna talk about the loss in terms of these variables. Okay, and I'll do that in 4.5. See you there.